In 9th class syllabus, there is one important topic that is regarding distance and the displacement. Before discussing about the distance and the displacement, let us start our brief definition regarding rest and the motion of the objects. My students, one thing you must clear in your minds: what is rest? An object is said to be at rest if it does not change its position with respect to surroundings with time. Yeah. If an object does not change its position with respect to surroundings with time, we call the object is at rest. There are various examples that you can quote in favor of the objects at rest. Okay. Similarly, if an object changes its position with respect to the surroundings with time, if there is change in position with respect to surroundings with time, we can call the objects are in motion. But whenever we are talking about the motion of an object, we have to talk that there are different types of the motions. In your syllabus, there is one type of motion known as rectilinear motion, second type of motion, circular motion, and third type of motion that is known as vibratory or oscillatory motion. Okay. So, in accordance with your syllabus, let's talk about the point. Dear students, the space in which we live is the three-dimensional space. So, in order to locate a particle anywhere in the space, we must be aware about three position coordinates. Yeah. In order to locate a particle, so what we will do, we will draw here three rectangular coordinate system. Yeah, in your syllabus, it is also known as Cartesian coordinate system. In this Cartesian coordinate, rectangular coordinate system, in order to locate a particle anywhere, we must be aware about three position coordinates. For example, this is particle P. We must be aware about X, Y, Z coordinates. If out of the three position coordinates, none is going to change with respect to time, we can call the object is at rest. Yeah. If out of the three only one position coordinate changes with respect to time, we call the object is in motion, and that special type of motion is known as one-dimensional motion, 1D motion. So what happens in one-dimensional motion? Only one position coordinate changes with respect to time. For example, if I am locating a particle here, this P is the position of the particle. Let me mention its position coordinates as 1, 0, 0. Yeah. And after some time, let's call it changes its position and reaches here. And the position coordinates will be 2, 0, 0, 3, 0, 0, so on. So we can call this type of object is in motion and is executing one-dimensional motion. Yeah, in one-dimensional motion, the object moves in straight line. Yeah, it moves in straight line. It can move along x-axis, y-axis, or along z-axis. Okay. If out of the three position coordinates, two are going to change simultaneously, two position coordinates. Two means it can be xy, it can be xz, it can be yz. Two position coordinates are going to change simultaneously. We call the object is executing the 2D motion. Yeah. If a boy is running on the straight track, how many position coordinates he is going to change with respect to time? Yeah, it is only one. So we can call that is the example of 1D motion. While if we are going to throw a stone, initially we are going to throw it with some velocity, then it moves under the influence of gravity. We call it as the projectile motion. Yeah, projectile motion. And remember, the projectile motion is the example of 2D motion. Or if a particle is going to execute circular motion is also the example of two-dimensional motion. On the other hand, if all the three position coordinates are going to change simultaneously, all the three position coordinates, we call the object is executing 3D motion. 3D motion, all the three position coordinates. And remember, in one-dimensional motion, the particle moves in a straight line. In 2D motion, it moves in a plane. It can be xy, xz, yz, or in three-dimensional motion, the object moves in space. Yeah, the motion of the gas molecules is the famous example in case of 3D motion. Now, students, try to understand the concept with the help of a simple graph. Let me draw here a graph. Along the x-axis, let's plot the time. On the y-axis, let's plot the position. Yeah, x of t. If the graph, position time graph, is a straight line parallel to the time axis, then we can call its position is not going to change with respect to time. Although the time changes here, but the position of the particle remains the same, and this is the condition that the particle is at rest. So remember, if position time graph of the particle is a straight line parallel to the time axis, then we can say the particle is at rest. Then in future classes, we'll be talking about the slope of this graph also. Okay. But if the particle is executing one-dimensional motion, one-dimensional motion, that is, if only it is one position coordinate changes with respect to time, it can be x coordinate, or y coordinate, or z coordinate. So it clearly means it can move along x-axis, y-axis, or along z-axis. Here we will be talking about two definitions. What is distance and the displacement? For example, if the particle, if a body starts its motion from A, after A it moves to B, C and D. Look here, the total path covered by the particle. This is total path. So this distance is basically the total path covered by an object. Total path covered by an object is known as the distance. Yeah. Since this distance is only having magnitude and no direction, so it is a scalar quantity. Remember, it is a scalar quantity. And the unit, how we can measure this distance, it is meter or centimeter. Okay, in CGS system it will be centimeter, MKS system it will be meter. Meter is the unit for the measurement of this length. And remember, this length cannot be zero, cannot be negative, it is always positive. Now, my students, try to understand, if we are going to join the initial position of the particle with its final position with the help of a line, a straight line joining initial position with its final position gives us the displacement. Yeah, displacement. So this displacement is having a magnitude as well as direction. So it is a vector quantity. Yeah, displacement is a vector quantity, can be positive, zero, or negative. Remember it. And its unit is same as that of the distance. That is, its unit is meter or centimeter. And dimensional formula same as that of the distance. Now, in your syllabus, my students, we have to talk about some of the numericals so that will help you in your 11th class examinations as well as in your future examinations. Oh, okay. Let's talk about them. Person moves from his home to school, straight line, at a distance of, for example, 2 kilometers. 2 kilometers is the distance of the school from his home. He runs directly and comes back to the position A. Can anybody tell me how much is the distance traveled? So distance will be equal to total path. What is total path? AS plus SA, that is 2 plus 2, 2 plus 2, that is equal to 4 kilometers. Okay. If he returns back to A, what is the displacement? Displacement will be equal to, yeah, that is equal to 0. Because initial and final positions are going to coincide. So under those conditions, the displacement of the particle is equal to 0. And one more thing we have to understand from this: if a person moves from his home to school, comes back and stays on the midway, okay, at the point O. So how much is the total distance and the total displacement? Total distance will be, my students, this 2 kilometer plus the path length from this to this point. If this is the middle point, so this will be 1 kilometer. So the total distance under this condition will be 2 plus 1, that is 3 kilometers. While as displacement will be equal to, displacement is the separation between initial and the final position. Now the final position of the particle is O, so it is AO. So that is only 1 kilometer. Yeah, you can do a number of the questions on the basis of this style. Okay. If a person moves on the circular track, just like this, having a radius, you can take any value. Let me take the value equal to capital R is the radius. And the person is going to start its journey from A, reaches to the point we can call here B, C, D, and finally to the point A. Okay. Now the question is, if the person moves from A to B, how much is the distance covered and how much is the displacement? Okay, can you tell me? Distance under this condition will be equal to, if a person is going to move from A and completes a circular track, then how much distance he or she covers? It is the circumference of the circle, which is equal to 2 pi times R. Yeah, exactly. If he or she moves from A to B, how much is the distance? Distance is, 1/4 of the total distance. 1/4 into total distance means total circumference, that is 2 pi times R. So that is equal to pi R by 2. Yeah, you can substitute the value of R. Okay, what is the displacement? The displacement is the perpendicular distance between initial and the final positions. So look here, my students. Here you know OA is R. What about OB? This is also R. So we have to calculate AB. Yeah, with the help of Pythagoras theorem, this AB will be equal to root of this square plus this square, that is R square plus R square, that is equal to root of 2 times R square, that is equal to R root 2. Yeah, R root 2 units. If in centimeters, then meters. Okay, so displacement will be equal to R root 2 from A to B. Okay, if there is a question, what is the displacement and the distance if a particle moves from A to C? Let's think about it. If a person moves from the point A to and reach to the point C. Yeah. So total distance covered will be equal to this much. A to C. Yeah, this is half of the total circumference. That is 1/2 into 2 pi times R, and that is equal to pi R. What about displacement? Displacement from A to C will be equal to, that is equal to this AO plus OC, which is equal to 2 times R, 2 times the radius. While as if a particle moves from A and reaches to the point D, A to D, what is the distance? Distance will be equal to, distance will be equal to AB plus BC plus CD, okay, that is 3/4 times the total distance, that is 2 pi times R. That is equal to, 3/2 times pi R. But what about displacement? My students, the displacement will be AD, which is equal to AB, and which will be equal to r root 2 units. And think about it, if a particle or a body moves from point A and finally reaches to the point A, how much is the total distance? A to A. Distance will be equal to, circumference. That is equal to 2 pi times r. And displacement will be equal to, initial and final positions coincide. So displacement will be equal to 0. Now by substituting the different values of r, okay, you can take if r is equal to 2 centimeter. If a body moves on the circular track of radius equal to 2 centimeters, 2.3 centimeters, okay, 5 centimeters, what will be the distance and the displacement under these different conditions? So thank you.